Greetings everyone. Today I, Utsav Gupta, is going to present a seminar on the topic of iPhone, activating mobile phone with your eyes. I hope this will be a very interesting seminar for all of you. Let's get ahead into the topic. So before diving into the topic iPhone, I want to think and ask all of you, what is the future of sensing? What is the future of sensor in our technological world? So according to me, sensor sensor technology is the future, as it will be getting more intelligent and more accurate in coming future, and the foundation of machine application is all about sensor technologies. And I will also make a bold statement of stating that products without the right application of sensor will find it extremely difficult and challenging to implement themselves in the current technological market. So that being said, let's head into the mobile phone sensing technology. As you know, mobile phone is the most basic and yet most touched technology we all use 24/7. So in mobile phones, that is the minimum requirements for the technology is 2 gigahertz of CPU and 1 GB of RAM. Although nowadays we use much higher end specs and high-end phones, but these are the basic requirements for various sensors like accelerometer, digital compass, microphone, Wi-Fi, Bluetooth, air quality, gyroscope, GPS, and lastly, and definitely not the least, camera. So light sensor or camera, as we say, is the most unexplored and high potential sensor we can use in our mobile phone. Front facing camera, as you all know, we can interact through this. I mean, I'm making this video through the front facing camera. It is the best sensor we can use to explore machine learning. And how can we use it? So basically, we can use two technologies: human phone interaction, namely HPI, and human computer interaction, namely HCI. Both goes like so. Human computer interaction, as the word suggests, it is a study of how people interact with computers and to what extent computers are or are not developed for the successful interaction with human beings. So it basically sums it up. We have to uh, set up the ideal computer with ideal situation and environment for this to work. And whereas in HPI, it is in human phone interaction technology. Researchers using HCI and are continuously searching for new approaches to reduce the effort users exert when accessing application on HCI, and hence HPI is created. Various applications we use, these are emotion assessment, in-car safety, and human phone interaction, as I told you all before. So why HPI? Why not HCI, you may ask? Why HPI? It's just basically because human computer interaction and human phone interaction, although they sound similar to layman, but they have a lot of difference. HCI is not as robust as human phone interaction, and that is because HPI extends the challenges that are typically found in HCI and are more specially related to the phone and how we use it. In order to achieve these goals, a human phone interaction technology should be less intrusive. That is, it should not rely on any external device other than the mobile phone itself. That is, it should be self-sustainable, self-efficient. It should be readily used with the minimum user dependency as possible. It should be fast enough in the inference field. It should be lightweight in terms of computation, and it should preserve the phone user experience. Example, it should not deplete the phone battery over no normal operations. So side by side comparison of HCI and HPI goes like this. HCI in fairly ideal conditions can be useful, but fairly ideal conditions are pretty hard to get, you all know. It uses an array of sophisticated sensors, very high demanding sensors, and subject has to be static for HCI to perform well. Sensing context is fairly constant. In HPI, though, subjects are on the move. Video frames, for example, you all know are very blurred. limited sensing capabilities. Obviously, in a mobile phone, you can't expect very high-end computation technologies and hence limited sensing capabilities and not ideal sensing context. For example, dark and bright, there can't be an ideal environment in an HPI. There are always hardware limitations with the phone. So as we have already talked about the technology used in iPhone, that is HPI, and we have talked why HPI over HCI. Let's get into the topic of iPhone and how the iPhone technology really works. So as shown in the presentation, there is a mobile phone and there's an eye, of course, of a user. So mapping of the position of eye on an application icon. So basically, the front camera of a phone detects where the eye is looking, where the pupil of eye is directing the vision. So it maps the position of the eye on the screen, which application it is watching, it is focusing on. See, first, if you can see, first the eye was looking at the above icon, then the icon change. So that is how it works. And finally, if we want to select the music application, it just blinks and voila, the application works. So that is basically how the iPhone technology was. But how it really works, what's the back end of it? What's the iPhone technology design? Let's talk about that. So in a research base, we use CPP and OpenCV technology and implemented on Nokia Tablet 810. And so how was the back end of the technology? Let's see. So first an eye template is created for different environments. So what is it basically? So tons of images of iframes are captured for a blink so that the machine knows what actually a blink of an eye is. As the machine is very naive, you all know, we have to make it learn what the really eye blink is. And the results of the binary images are the eye pair. As you can see, running on a PC and running on Nokia 810 is really different, and that is basically the difference between HCI and HPI. We have already talked before. After the eye template creation, eye tracking is the way to go. On every frame, eye is tracked based on the correlation function operating over the current frame and the template. Eye tracking is done. So as you can see, there are nine ways in which an eye can be tracked. That is how the machine learning has been set up. So namely top left, top center, top right, middle left, middle center, middle right, bottom left, bottom center, and bottom right. So these are the nine basic views where an eye can track on the mobile screen. Going ahead, wink detection. So yeah, first first we created the eye template so that the machine knows what an eye looks like, what happens after it blinks, and how to track the eye. After that, it tracks where the eye is looking, and now the wink detection technology, based on the correlation function value used in the tracking phase, is the same as that. And now the evaluation, how the results were made, how the how did how the technology after implementation worked really. So let's see experimental results. So this is table achieved through the accuracy standpoint of view of various direction in which the eye can be uh, looking, in which an eye can be winked, which an eye can be tracked. So as you can see, this is the steady daylight conditions, and we have all the list of all the direction where the eye can look at. As you can see, in the current data of the steady daylight situation and environment, we have scored pretty good accuracy, ranging from 80 to 95 and almost touching 100. So we can say it is a good accuracy statement, and but still it needs a scope of improvement. Going ahead, we have steady and yet but artificial light conditions. It is we can see the trend. It can be compared with the daylight situation, but still, as we know, it was considerable that the accuracy would drop, and it has certainly dropped. Not to a much extent, but certainly it has dropped because due to low light situations, the sensor would not be able to pick more eye blinks on higher frequency. Going ahead, if we have walking daylight conditions, we can see it is it is really it is really comparable results with the daylight steady condition, but still, as the walking has now come into play, the basic the basic understanding is that the accuracy would obviously drop, and it has certainly dropped. You can see it has certainly dropped, and the average comes out to be around 70. Now let's talk about the accuracy versus distance from the display, from the sensor, actually tracking the which is actually tracking the eyeballs. So yeah, we can see eye tracking accuracy for the middle center position as a function of different distance between the display and the eyes when the person is steady and walking. You can see in both cases, that is steady and walking, the accuracy has dropped severely after it is reached the distance of 30 centimeter and more. You can see the graph is really slopey. You can see that's what the research should be made on, and we can really look forward to the more advanced technology in future. You can see the downward trend of the graph and how it is severely dropping after 30 centimeters. So after learning about the technology, what we should talk about is the possible applications of this technology. Beyond touchscreen, yes, we can definitely use the eye menu technology, which is basically using phone without touch, without keypad, just looking through the phone and controlling the phone. How amazing it would be! Just you can all you can all assume how great that would be. So what basically this technology means is that we can really control our whole phone through our eye movements. That is really great. So let's recap what we have learned. We have discussed smartphones computation capabilities are growing. You all know the base now. The high-end mobiles are as comparable to uh, desktops even and the laptops even. Smarter OpenAI template creation policies are needed to be robust across different contexts, different environments, for example, low light conditions and moving conditions. So there should be more creation of the templates. I so again, eye tracking techniques that are robust against context, mobility, and distance from displays is the need of the eye in this context of the technology. More efficient false eye pair and false wing filtering to avoid undesired app launches. That is mainly one of the drawbacks of this technology in the current scenario is the false eye pair and false wings filtering to avoid undesired app launches. In brief, mobile phone sensing technology and HPI technology are the future. As we have talked before, we, with the current boom in the sensor technology, this is really the way to go. Thank you. I hope you have learned something about this technology, and I hope this was a really fun seminar you have attended. Thank you.